Hello everyone, today I'm going to talk to you about the structure of the atom. In order for me to tell you about the structure of the atom, I have to introduce you to two characters. My first one is going to be this guy. He is a positive and he is a rather good player at the game. He is a proton. He is a pro at the game. Now his enemy for today will be the electron, and please notice how he has that negative sign on him. The proton is positive, whilst my electron is rather negative. Now my proton is so good at this game, in fact, he gets a bit of a sidekick. Now this sidekick is so new to the game, in fact we call him the neutron. Alright, he is new and he pretty much doesn't know how to play the game, so he is going to sit on the sideline for most of the game while these two compete against each other. Now this is rather important because it does help us figure out the structure of an atom. Now, if we were to place this into a structure of an atom, what we would first need is the playing field. So here's my playing field in the middle. We can call this the playing field for this competition. And if I was to put my teams on the field, well, I would first put my proton on the field. In fact, he will stand right in the middle of the field because he knows what he's doing. The neutron, on the other hand, has no idea what he's doing, so he'll stand right alongside my proton. Now together they form a rather unique team, and we call them the nucleus. Now my electron is also playing, and he is competing as well, except my electron's a little bit sneaky. He likes to hang around the edge of the playing field. In fact, he likes to rotate around and try and find the weakest point. In fact, he is constantly floating around there, but for today, we will put him on the side there. Now, just how on earth do we figure out, well, how many of these people are playing? Well, how many electrons do I have on the playing field? How many neutrons? How many protons? Well, all of this depends on one important thing. It kind of depends on this. This is our periodic table. Now our periodic table is a guideline to our elements and actually tells us where our elements are. It also tells us a little bit of a secret. Because if I was to take an element, let's say I was to take helium here, so helium being up in the top corner, if I was to take helium and put it on our playing field, well, we could sort of use this as a rule card. Now, if I was to use this as a rule, well, I would first need to know its parts. Well, the first thing I would tell you is, well, the simplest one is its name. What's the name of the game? Well, in this game, we're calling it helium. Now, the game has a nickname as well. That's the one just above it. And we refer to it as being a symbol. Now, the symbol for this game is helium. Other elements to this box will have the top number. Please notice how this is the smallest of the two numbers. The smallest of the two numbers is referred to as our atomic number. The bigger of the two numbers, the one down the bottom here, is referred to as our atomic mass. Now, our atomic mass is that number down there, as I said, and our atomic number is the number at the top. Now, these two are our most important ones, because as I said, they can be treated like a rule card. In fact, if I was to take these two away and move this onto the side, our atomic number kind of tells us a bit of a story. Our atomic number, so that being the smallest of the two numbers, tells us how many players are allowed on the field. Now remember, our players in the game are the two individuals we have met before. That would be my proton and my electron. They are the two people running out on the field. Not my neutron. My neutron is too new to the game, so he is going to sit on the bench. So if I've got my proton and my electron, I need to figure out how many of them I'm allowed on the field. Now, as I said, my atomic number tells me this. In fact, it tells me it rather easily. The number 2 there tells me how many people I'm allowed on my field. So in the case of my protons, I'll be allowed 2 on the field. In the case of my electrons, I would also be allowed 2. Remember that we have to have an even amount of players on the field, otherwise it's unfair. So my protons and my electrons have to be the same amount, and they all relate to my atomic number. Now, how on earth do we figure out our neutron? Well, remember how I said my neutron likes to chill on the bench? Well, consider my atomic mass, that's this number down the bottom here, tells us how many players are on one team. Now remember, the team's name was called the nucleus that the proton was on. Well, my proton and my neutron make up my nucleus team. So if I know that I have 2 protons and there are 4 players in that team, I can sort of work out how many neutrons I have. If I have 4 players on my team and I have 2 players on my field, remember, these are the 2 players that are playing on my field, my protons, I can take those 2 away and work out the difference. In this case, my difference would be 2. We can therefore change that name to my neutron. My neutron in this case would be 2. Take away the equation, and there we go. Now, how would this look on my lovely playing field? Well, let's see. Now I know for this playing field I need 2 protons. So let's put our 2 protons on the field. As I said, my protons like to hang out in the middle of the field. Now my neutrons don't really know what they're doing, do they? Instead of sitting on the bench, they wander onto the field accidentally, and they kind of huddle around my protons. 2 neutrons, 2 protons. Now the 2 things that I am missing are my 2 electrons. Now remember, my electrons were very, very sneaky, and they like to hide on the edge of the field. And this, ladies and gentlemen, is how we do a basic structure of an atom.